everyone! So these days I don't really do a lot of geometry and algebra and contest problems on this channel. I focus mainly on calculus, which is sad. So to fix that, today we'll be doing a problem from the Chinese Gaokao. And it's one of those problems where everyone just went wow about it. But before we get into it, I would like to address something that I have said in the past, but I just want to say it in my video so that everyone knows. So have you noticed how recently comments have been disabled on my videos? Well, it's not me. I don't like to disable comments. I really like to have comments. But apparently, YouTube has been criticized for failing to protect children from predatory comments, which is why it decided to turn off comments on all videos that feature children, including mine, because as far as I know, I'm not 18 yet. And that is very sad. Again, one of those stories where the few people ruin it for everyone. So yeah, I just thought I might say in the video so that everyone knows what's going on. And with that message out of the way, let's get into it. So what's our problem? Well, we have in the Cartesian plane a line L with the equation x minus y minus 2 equals 0, and a parabola C with the equation y squared equals 2px, for p being strictly greater than 0, which makes sense because if y squared were to be equal to 0, then y would be equal to 0, which means we just have a line, which is boring. So, part 1. If line L passes through the focus of our parabola C, then we want to find the equation of C. And part 2 has two parts. So, we have 2 points P and Q that lie on our parabola C and that are symmetric about line L. Part A of part 2, we want to prove that the midpoint of segment PQ has these coordinates. And part B, we want to find the range of P, so the interval that P must lie in for this to hold. Okay, so let's get started. We'll start with part 1 because it's the easiest. So yeah. Let's start with finding I'll just write part 1 just to be clear. Okay, so first we'll find the coordinates of our focus. So our focus, which we'll call F, will have coordinates. Okay, so the y coordinate will be 0 since it's a sideways parabola, meaning the focus will lie on the x-axis, and the x coordinate will be 1 over 4 times 1 over 2. Wait, is that right? Yeah, it's right, because as we know, the equation of our parabola is y equals ax squared or x equals ay squared, and the focus is at either 0, 1 over 4a or 1 over 4a, 0. It's just a natural consequence of the derivation of the equation of a parabola. So and our a in this case is 1 over 2p, because if you divide both sides by 2p, you get x equals y squared over 2p. And we can simplify this because in the denominator you get 2 over p, so take the reciprocal of that, we get p over 2. But then F, by definition, lies on L, meaning that, x, which is p over 2, minus 0 minus 2 equals 0. 0 can just, be erased. And if we solve this equation for p, we get that p is equal to 4, obviously, because if you plug in 4, we get 4 over 2, which is 2 minus 2, which is 0. Meaning, if we were to plug it into our equation for c, we will get c equals y squared, c is defined by y squared equals 8x, and that is our solution for part 1. And now let me erase this space because we'll need it for part 2. Okay, so let me just write that this is part 2. And to clear things up, originally I thought that part 2 was dependent on part 1, which means the equation was y squared equals 8x for all of this, but it is not. The formulation might not be exactly clear, but on the website that I found this problem, it was translated from Chinese, which makes sense because the Gaokao is held in China. Okay, so back to the problem. So first, what we'll do is, before we prove any of the two parts, we'll do some preliminary work. And that preliminary work will actually be most of the work. So first, we'll let P have coordinates. Well, the y coordinate will be A, let's say. Meaning, since P lies on C, the y coordinate will be A squared over 2P. As I said again, divide both sides by 2P and you get your equation in terms of x. Well, x as a function of y. And then what we'll do is we'll let R be the intersection of PQ and L. I'll actually write this as the line going through PQ so that it's clear that it is actually a line and not a segment. Okay, so now let's find the equation of line PQ. So, we know that P and Q are symmetric about line L. And that must mean that the segment PQ, or rather the line PQ, is perpendicular to L. So, well, since the slope of L is 1, actually, let me rewrite the equation of L a tiny little bit so that it's obvious that it's in slope-intercept form. So we get, adding y to both sides, y equals x minus 2. And from this we get that the slope is just 1 of L, meaning the slope of Q will be negative. Well, the slope, okay, let me formulate it again. The slope of L is 1, meaning the slope of PQ will be negative 1. So we have y equals negative x plus some constant c. But we have to figure out what our c is. And for that, we can just plug in our coordinates for p into our equation to get a equals negative a squared over 2p plus c. And if we solve for c, we get that the equation is actually a squared over 2p plus a. And now we can solve for the coordinates of r. So for r, well, we know that r is the intersection of line PQ and L. And to find the coordinates of r, we can just set both equations equal to each other, which means that we have x minus 2 equals negative x plus a squared over 2p plus a, meaning that move the x terms to one side and the constant terms to the other, well, the terms that are not with respect to x, and we get 2x equals a squared over 2p plus a plus 2. Divide both sides by 2, we get a equals a squared over 4p plus a over 2 plus 1. And if we subtract, we can figure out our y by subtracting 2 from both sides, meaning that y equals a squared over 4p plus a over 2 plus 1 minus 2, which is minus 1, meaning overall that r, that was an ugly r, that's a better r, is equal to, has coordinates a squared over 4p plus a over 2 plus 1, comma, a squared over 4p plus a over 2 minus 1. Good. And now let's find the coordinates of Q. So we know that Q is the intersection of line PQ and C. So we have the system of equations. Well, the equation of line PQ is y equals negative x plus a squared over 2p plus a, and x equals y, y squared equals 2px. And now we can just plug our equation for y into our second equation to get, I'll just square it directly. Wait, was that how I did it? Yeah, no, that is different. No, actually what I did is, we'll solve for y first. What we'll do is we'll isolate x to get x equals a squared over 2p plus a minus y, and then plug it into our second equation to get y squared equals, multiply that by 2p, so we have a squared plus 2ap minus 2py, meaning that y squared plus 2py minus a squared plus 2ap is equal to 0. And now we can just solve this as a quadratic equation in y to get y equals negative 2p plus or minus the square root of 4p squared, and then minus, it's minus 4 times 1 times this, so we'll have plus 4 times a squared plus 2ap. Divide this all by 2. And now we can see that we have a common factor of 4, so we can factor it out. And actually we can divide we can divide through all of the 2's. And the inside right here is exactly the formula for a plus p. So we have that y equals negative p plus or minus a plus p, because it's the square root of a plus p whole thing squared. And now we have two cases to consider. Meaning, first case, the positive branch, meaning y equals negative e plus a plus p, which means y equals to a. And the negative branch is y equals p minus a minus p, or y equals negative a plus 2p. But then the first case doesn't work because the y coordinate of p is already a, meaning these two would have the same y coordinate and they are symmetrical bound like L, meaning they would be just, the same point, which would be boring. And if you actually do the calculations, you'll find that it'll break down at some point. So it means that we have to reject this solution, and we can only accept our second solution, meaning that if I have the space to write everything, x will be a squared over 2p plus a minus y, so plus a plus 2p, which is a squared over 2p plus 2a plus 2p, meaning overall that q has coordinates a squared over 2p plus 2a plus 2p, comma, negative a plus 2p. Hold on, I just want to check if I did any mistakes, because those are some really cumbersome calculations and I don't think I made any mistakes. Okay, so now I'll clean up this part of the board, and now that we have our coordinates for P, Q, and R, we can use the condition that for P and Q to be symmetrical about line L, PR must be equal to RQ, and we can use that to solve for A in terms of P, which will in turn allow us to answer our two questions. Okay, so now that I cleaned up this board, we can continue on with our problem. And as I was saying earlier, before the transition, and I just started, we can compare the distances between PR and QR, set them equal to each other, and then from that we can solve for A in terms of P. But then, here's the thing. Let's zoom in to segment PQ. So this is PQ. R, this is equal to this. And now, the slope of PQ is -1, meaning the angle it will make with the horizontal is 45 degrees. Meaning that these two triangles that I had to construct are actually right isosceles triangles. So this means that to compare the distances between PR and QR, it suffices to compare the distance between either two of their coordinates, either the x coordinates or the y coordinates. So let's do PR first. So we have to put absolute values because the quantity inside, the difference might be negative, but we want it to be positive for our purposes. So we get, which coordinates? Let's compare the y coordinates. So we have a squared over 4p minus a over 2 minus 1 is equal to, and now for these two, we'll compare the y coordinates again. A squared over 4p plus 3a over 2 minus plus 2p minus 1. I'll leave the specifics to you on how I got this. And now, from this, we have two cases. Our first case is a squared over 4p minus a over 2 minus 1 equals a squared over 4p plus 3a over 2 plus 2p minus 1. In other words, if we just cancel out the absolute values right away. And our second case is if one of the arguments of the absolute values was negative what it is. So we have negative a squared over 4p plus a over 2 plus 1 equals a squared over 4p plus 3a over 2 plus 2p minus 1. Look at that. If you take the absolute values on both sides, you get the same thing. So let's first look at case 1. So we get a squared over p cancels here and here. Negative 1 cancels here and here. So case 1 implies that if we add a over 2 to both sides and divide by 2, we get a equals negative p. So the y coordinate of p is negative p. But then negative a plus 2p, the y coordinate of q will be, the inside will be p, so we have negative p. The y coordinates will be equal, meaning the x coordinates will also be equal, meaning p and q will actually be the same point, and this is boring. It's not useful for our purposes, and also I think the calculations will break down at some point, but I'll leave it to you to check that. So case 1 is bad. And that leaves us with case 2. So what we can do is we can bring everything to the same side of our equation. So we get a squared over 2p plus a plus 2p minus 2 equals 0. Because we brought this to the other side, this to the other side, this to the other side. And we'll group these two into parentheses since they are independent of a. And then we'll multiply both sides by 2p, so we get a squared plus 2pa plus 4p squared minus 4p equals 0. And now this is just a quadratic equation in a that we can solve. So we get a equals negative 2p plus or minus 4p squared minus 4 times 4p squared minus 4p times 1, the coefficient of this one, but we don't care about it, all divided by 2. And now, what can we do? Well, the 4 can be brought outside of the square root to give us, well, 2 times the square root, but then the 2's can be cancelled out, so we have negative p plus or minus the square root of, and if we simplify the inside, we get 4p minus 3p squared. And now, it seems that we have both a positive and a negative branch to consider, but actually, they will give us the same outcome as we will see soon, and since we have our value of a, we are finally ready to answer our 2 questions. So, well, I'll clear this board and we'll answer actually our 2 questions. Okay, so now that I've cleaned up this board, we can finally start answering our 2 actual questions. So, let's answer part A first. Now, we want to find the coordinates of the midpoint of PQ. But the midpoint of PQ is R, exactly, because it's the intersection of PQ and L, and since everything is symmetric, we get that R is actually the point that we want. And all that we have to do really is just to plug in A inside of our formula for R, and we're good to go. So, let's first focus on this a squared over 4p plus a over 2 quantity because it's in both coordinates and it allows us to just add 1 and subtract 1 as we need. So let's plug in a. So we have negative p plus or minus the square root of 4p minus 3p squared all over 4p plus a, which is negative p plus or minus the square root of 4p minus 3p squared all over 2. And now we'll expand this bit right here, the numerator of our first fraction. So we have p squared, and then 4p minus 3p squared, squaring this term, and the plus minus will go away. And then 2, the sign will be negative plus or minus, so negative, so minus plus 2p times the square root of, well, things. I won't write out everything, so I'll just write the square root of some things, all divided by 4p, and then plus negative p plus or minus the square root of things over 2. But then we can multiply the top and bottom of this fraction by 2p, so we get 4p here, 2p here, and negative 2p squared there. But then, if we add those two, because they have the same denominator, these two terms will cancel out, because if we have negative and plus here, these will cancel out, plus and minus, these will cancel out. And then basically, what we have is, well, we can just combine actually, so we get 4p minus 4p squared all over 4p, cancel out the 4's, cancel out the p's, and we get 1 minus p, which means that x is equal to, well, this quantity plus 1. So actually, let me write this the following. So we have r is equal to, x coordinate will be 1 minus p plus 1, so 2 minus p. Y coordinate will be 1 minus p minus 1, which is negative p, which is exactly what we wanted up there. And hence, we can put a QED sign. And now I think I'll have the space to fit in part B. So part B is, well, we want to find the range of possible values of p. And, well, for a to exist, for a to be real, the inside of the square root must be greater than or equal to 0. Because if it's negative, this thing is going to be complex, and a is going to be complex. But a is the coordinate of a point in the real plane, meaning it just can't work. Okay, so we get that 4p minus 3p squared must be greater than or equal to 0, which means that p times 4 minus 3p must be greater than or equal to 0. And now let's make ourselves a nice little number line. This is big, this is small. And now, at 0, this will just vanish to 0. And our other root is 4/3, because if you plug 4/3 in, this goes to 0. 0 times 4/3 is going to be 0. So at 0 and 4/3, this is just going to be 0. And then between 0 and 4/3, we get that, well, if we take a look at 1, which is between 0 and 4/3, we get p equals 1 here, and then this term equals 1, so we have 1 times 1, which is 1, which is positive. So positive right there. If p is larger than 4/3, so let's say 2, we have 2 times negative 2, which is negative 4, so this is negative. And if p is less than 0, so we have negative 1 there, and then 7 there, which is negative 7. So things are negative before 0. So we have that p must be within this range, but we can't include 0 because by definition p is greater than 0, meaning that p must be, actually let's write this into interval notation. P must lie in the interval from 0 to 4/3, including 4/3, but not including 0, and hence, this is our answer. And For the record, while filming this video, I did quite a few mistakes. First one was, when I did the absolute value thing, I messed up some terms. Second one was, I forgot to take into account the negative branch, and well, I just found out that these give the same thing. But yeah, I understand why, as I said at the beginning, everyone will laugh about these questions, because the Gaokao is a kind of exam to ask really weird questions, because I saw on the website once, there was a question on the Gaokao. It was a writing question. It was like, I have my notes up there. Like, mixed milk is stored in square bottles. Water is stored in round bottles. Wine bottles, which are round, are stored in square boxes. Write a text on the subtle philosophy of the round and the square. Yes, this actually was a question on the Gaokao. I would have no idea how to answer this, so I'm just going to stick to math questions for now. Okay, so yeah, this is the video. Thanks for watching the video. Like, share this video. Bye.